Hi, and welcome to Lesson 3.7, Formulas and Functions. So in this lesson, we're going to look at the main idea that formulas and functions can be rearranged to solve for any of the variables that you're looking for. So we're looking at the idea of rearranging formulas and functions to make it easier to arrive at your answer based on solving for the variable that you're looking for. So let's make sense of that idea with a few examples. So in example 1, it tells us to use the formula for area of a rectangle. And that formula is area equals length times width. They want us in part A to find the formula for L in terms of A and W. So finding the formula for L means we want to solve that equation, A equals L times W, for L, or we want to isolate L by getting it alone. So if our original equation is A equals L times W, to solve for L, we would divide both sides by W, and the length would equal area divided by the width. So then in part B, we can use our new formula to more easily solve for the length of the rectangle with an area of 35 square feet and a width of 7 feet. So our length equals area divided by width. So area, 35 square feet, divided by our 7 feet. 35 divided by 7 is 5, so the length would equal 5 feet. So we can rearrange the original area formula to more easily solve for length or width if we choose to. In example 2, we're dealing with the temperature formula, and in this case, it's the relationship between Celsius and Fahrenheit. So our original formula is degrees Celsius equals 5/9 times the quantity, degrees Fahrenheit, minus 32. So the capital C is Celsius, F is Fahrenheit. They want us to solve for F. So we want to get F alone. So if our original equation is solved for C, we can take that original equation, and because of the 5/9 here, I want to cancel that out first. So technically what I do is divide both sides by 5/9, which is the same as multiplying by the reciprocal. So we're going to multiply each side by 9/5 to cancel out this 5/9. So then what we have is 9/5 times C equals F minus 32. To get F alone, we'd add 32 to each side. So degrees Fahrenheit equals 9/5 multiplied by C plus 32. And that is the equation that you would use to convert from Celsius to Fahrenheit. This original equation here is to convert from Fahrenheit to get your degrees Celsius. Then in example 3, we're dealing with the simple interest equation. So simple interest, letter capital I, on an investment of P dollars, so P represents dollars, interest rate R, and years, letter T, is given by the equation I equals P times R times T. Part A wants us to solve this equation for R. So to start with, we could divide both sides by either T or P. So I divided by T first, and I divided by T equals P times R. So to solve for R, we would divide both sides by P, and our R, the interest rate, would equal the simple interest divided by the principal times time. So R equals I divided by P times T. So then we're going to use that interest rate equation to find the interest rate of an investment of $1,500 that earned $54 in interest in 1 year. So if we earn 54 in 1 year, my apologies here, that 1 should be on top, 54 times 1, we have, or no, 1's on bottom. I'm losing my mind here. P times T is on bottom. So on top, R equals I. I is the simple interest. So $54 goes on top. Then on bottom, we have our principal investment, $1,500, multiplied by the amount of time, 1 year. So 1,500 times T. So R would equal 54 divided by 1,500, which is 0.036. Now you can leave a rate as a decimal, but if they wanted us to figure out what percent the rate was, any decimal times 100 turns it into a percent. So we would do the 0.036 times 100, so that gives us 3.6%. So you could give your answer as this decimal or this percent. And then example 4 asks us to rewrite the equation so that y is a function of x. So if something's a function of another piece, it means it's the output. So that tells us we want to solve for y or get y alone. So y being a function of x means solve for y. If it said x is a function of y, we would solve for x. So we want to rearrange the equations in A and B to solve for y. So in A, 3x plus y equals 4. We could subtract the 3x from each side, and y would equal 4 minus 3x, or we could rewrite that as a negative 3x plus 4. Now, the reason you would possibly want to rewrite that is traditionally in the most acceptable form, the variable part's going to come first on the other side of the equals. But I would take either answer. In B, to solve for y, we have 3 times y minus x equals 12. So first we have to add x to each side. So we have 3 times y equals 12 plus x. Then we'd want to divide all parts by the 3. So y would equal 4, and then x divided by 3, or x over 3. So y equals 4 plus x over 3, or we could rewrite that as y equals x divided by 3 plus 4. So the main idea for today's lesson goes back to just our title of formulas and functions, and that we can rearrange or solve for a certain letter or variable to make our functions and formulas easier to understand and easier to use in certain circumstances.